Okay, so let's talk about implicit differentiation today. Let me share my screen. Yeah, this screen I have to share. Here it is. Okay. So implicit differentiation. All the functions that we have differentiated so far have been of the form y equals f of x. These are called explicit functions. Explicit functions are of the type y equals 2x plus 1, y equals x square plus 4, y equals 1 by x. All the functions where you can make y the subject, where you only have y at the left hand side, are basically the explicit functions, because in these cases you have explicitly expressed y in terms of x. Okay, there's no mixture of x and y. Things are separated. We have x terms on the right side, and on the left side we have y, right? So things are clear in these cases. Okay, but this is what we have been doing. We can either solve it by using the quotient rule or by the product rule or whatever rule we want to. This is what we have been doing. Now we are going to talk about a different type of question. We are going to talk about such a case where you have been given with this type of equation. This is also an equation, this is also an equation, and the question is saying you need to find dy by dx. Now, in these cases, things were very simple. We used to differentiate both sides by x. Let's say this one. So we used to do it this way. Dy by dx equals 2. Done. But in this case, we have x and y mixed. So we need to use chain rule as well as the product rule. How? I'll tell you. The only thing you need to know is that for implicit differentiation, you will be using the chain rule and the product rule, right? Clear?
Yes.
And the other thing is you need to be clear with what implicit and explicit is. Okay, so these are the examples of explicit. But if I have yx plus 1 equals 2, or if I have yx square plus y cube equals 1, these are implicit functions. Why are these implicit functions? Because x and y are mixed over here. I cannot easily, okay, in this case, I can separate y easily. I can make y the subject. But in cases like these and like these, when you cannot make y the subject of the equation, when you cannot explicitly write y in terms of x, we use implicit differentiation to solve such cases. Okay, the question is same, to find dy by dx. Okay,
Yes.
right. So by now we know what an explicit function is, we know what an implicit function is, and we know that we'll be using the chain rule and the product rule. This is the chain rule and this is the product rule. Okay, now let's see, let's look at an example and see how are we going to apply the chain rule and product rule. Okay. Okay. This is the question. Let me make it bigger just so you can read it easily. Let me know once it's readable, okay? It's readable, but it's not that clear,
Yes, it is.
right? Okay. So let's talk about No, let's talk about the second part first. Okay, let's not talk about the first one. Let's talk about this part. I know it's not that readable, but I will rewrite things so you would be knowing. Okay. So here the question was to differentiate this type of an expression. Okay. Unlike what we have been doing, we used to solve questions of this type d dx, and the functions over here used to be in terms of x only. But now things are different. Now we have y as well. So this is your clue. Now you know that you will be using implicit differentiation. Okay. So this is the clue that we have x and y mixed. Now, how are you going to do that? Okay. Just like um, our previous examples, where whenever we had two functions of x, let's say this is the first function and this is the second function. Now you can say that, ma'am, I can only see y over here. Where is the x? But this y is in terms of x. Okay, this is given. This is an assumption. This is something that you should know. So whenever you have a mixed type of a question and you have been asked to differentiate it, make sure that you know this y is in terms of x. Okay, so when we have this thing written like this, we basically have two functions of x and we have been asked to differentiate. So things are same. We will use the product rule. First function would come as it is. We need to derive the second function. This is what we have written. D dx y to the 5. Okay, this is what derivation of second function is. Plus second function would come as it is, and we need to differentiate the first function. So this is the differentiation of first function, right? They have not written down the differentiations in first part. Okay, they have just written down d dx directly. They could have written 8x, but no, they want to do things in steps. Now 4x squared would come as it is. This, they haven't simplified it. Again, they have written it in a similar way. Plus, the derivative of 4x squared is 8x, right? And this y to the 5 would come as it is. Is it clear till this step?
Yes.
Okay. Next, they have differentiated this part using the chain rule. And this is why the chain rule is used. Okay. So the chain rule says, let's say if we have yeah, we used to use this way: dy by dx equals dy by dt into dt by dx, right? This is how we used to operate the chain rule. Now this y and this x, they are not variables which we would say are fixed. No, it is not like that. We prefer using y and x most of the times, but in this case, this y to the 5 is y basically. This is our y in this case. Okay, if this is our y, if this y to the 5 is our y, so we would have dy because there is no dt, and then we will write dy by dx. So dy to the 5 with respect to dy. What is the derivative of x to the 5 with respect to x? 5x
Fx
to
to
the
the
4.
power 4.
Excellent. So this would be 5y to the power 4 into dy by dx would come here as it is. We don't know the answer to dy by dx, okay? But we know this. So never ever think that chain rule is always dy by dx equals dy by dt into dt by dx. I mean, it is this, but your variables can change. In this case, instead of y, we have y to the 5. When we have y to the 5 here, and so basically we will be differentiating y to the 5 with respect to y. We cannot differentiate it with respect to t. Okay? You will practice questions, so you will get better at it. Right. So this is 5y to the 4 into dy by dx. And when I multiply it with 4x square into 5y to the 4, this would be 20x square y to the 4. Dy by dx would come here directly, plus this term would come here directly. Okay? I'll explain this and then you'll understand even more. Okay. Again, you have been asked to differentiate an expression. Now, this expression is a mixture. You have y, you have x, and you have a clue that this is the case of implicit differentiation. Right. This is what we know. Okay. So again, we will be differentiating this function and we will be differentiating this function. This is what they have written. Derivative of x cube plus derivative of this thing. Derivative of x cube is 3x square and derivative of this function. Now again, this is x is f of x and y is g of x. Okay, I've already told you that y is a function of x. So whenever they are written like this and you have been asked to differentiate it, you need to use the product rule. So the product rule says first would come as it is. You need to differentiate the second one, this one, plus second would come as it is and derivative of the first one. Okay. So 3x square would come here, 5x, dy by dx and 5y. Now this dy by dx, you could have said that, ma'am, why are we not using the chain rule here? Because this dy by dx is already simplified. Okay, this is simplified. You cannot simplify it further. This is simplified. This is already simplified. In this case, we had y to the 5 divide we had to differentiate y to the 5. This is not simplified. We simplified it and our simplified expression had this dy by dx. So we did not simplify this dy by dx further. We just leave it and we will use it further. How? I'll tell you. At the moment, you're just seeing how to differentiate this type of expressions. Is it clear?
Yes.
Are you sure?
Yes, it is clear.
Okay, let's talk about the first one now, the one I have missed. I'll get new whiteboard and then we'll do it. So what is your clue in case of parametric equations? The ones we
Terms of
discussed.
parametric equations, there will be like something like theta or t or something like that.
Yeah, very good. And in that case, the number of equations would be 2. Okay?
Yeah, two.
Yeah, very good. Where is the question? Where's the question? Okay, so right. So this was the first question, and I told you this is f of x. This is something in terms of x, but you don't know what it is. Okay, so you cannot just write down 0 over here because one might say that there's no x over here, and if I'm differentiating it with respect to x, I'll write down 0. No, never ever do that. This y is in terms of x. So how would you do that? You'll use the chain rule. Okay, you have dy cube dx. So by using the chain rule, you will differentiate it with respect to y and then dy by dx. So when you differentiate y cube with respect to y, you have 3y square and this dy by dx would come here directly. It would come here directly. Okay?
Yes.
Is it clear?
Yes, it is.
Okay, very good. So I'll do a, a, another example with some more details. Let me just take out the example. I have it on my phone. Okay, I'll use the other whiteboard. I don't like this whiteboard at all. Okay. So the question is, find dy by dx for curve x cube plus y cube equals 4xy full stop, right? And then they're saying, hence find the gradient of curve at the point 2 2. Okay, now I want you to notice a difference. Here they have asked you to find dy by dx. The previous questions were of this type, right? The previous questions were of this type. You had to derivate this function. The question was not saying to find dy by dx. So the steps which we'll be following initially are going to be the ones which we have just discussed, but then there would be an additional step to find dy by dx. Okay, in previous questions we have not been finding dy by dx. You must be, you wait, let me just do it. We just did this example. So we said that in such a case we'll be using chain rule, and this was the case. So 5 by to the 4 dy by dx. So in previous examples, we just ended up over here. We did not find dy by dx. Okay, we had dy by dx in our expression. We were just asked to differentiate this. But now they are asking us to find dy by dx. So let's see how are we going to do that. Okay. Okay. Right. So step 1, we'll differentiate this whole equation with respect to x. Okay, so we will differentiate x cube plus y cube with respect to x, as well as we'll differentiate this side as well. Okay, now once we have been asked to differentiate this, so this is basically x cube dx plus d dx y cube equals, now here I can directly, what rule am I going to use here?
The chain rule.
No, we have two functions that are being multiplied.
Product rule.
Very good.
Product rule.
Okay, so please help me. Okay, how am I going to apply the product rule? First function would come as it is. Let's say 4x is the first function. Derivative of the second function with respect to x. What is the second function? Second function is y plus, what am I going to write?
Uh, Plus the derivative of the first function.
Very good. That is
X cube. 3x square.
no. I'm talking about this part. Derivative of this function.
4.
Very good. And What would come as it is?
Y.
Okay. What is the derivative in this case?
3x squared.
Very good. And how am I going to solve this part?
D by dx of y cubed.
Yeah, how am I going to solve this? How am I going to differentiate this?
3y squared.
3y square, but no, but this is x. How can you say 3y square? We are differentiating it with respect to x. You can write 3y square, but when you are differentiating it with respect to y. So here we are going to apply the chain rule. Okay. So we will
Oh,
write this divided by dy into dy by dx. This is what we wanted. This is how we apply the chain rule. And I told you a tip just to memorize. Just imagine these dy's, we can cancel them. Okay. Although you cannot, never ever do that. But just for the sake of learning or for memorizing this. So you would be left with these two. So this is how you apply the chain rule. Okay. We just cancel out these. Right. And this side would come as it is 4x dy dx plus 4y. So we have 3x square. And now what is the answer? What is the simplification of this part? Derivative of y cube with respect to dy.
y cubed.
Sorry.
3y squared.
Very good. And this would come as it is dy by dx.
Dx.
Okay, now I'll take this to this side for a reason. 4x dy dx, and I have 4y minus 3x square. I've taken this 3x square to that side, so I'll rub it from here. Okay. Now why am I not being able to write? Okay, finally. Yeah. And now I can take dy by dx common over here. I'll write 3y square minus 4x equals 4y minus 3x square. So dy by dx is 4x minus 3x square divided by 3y square minus 4x. And we had to find the gradient at this point. So I'll simply plug in 2 and 2. This would be 4. This is 3. This would be 4 minus 4 into 2. And we have to simplify it. Okay. Now listen. The question was to find dy by dx. And this was the equation. And x and y are mixed over here. So instantly we know that we'll be using implicit differentiation. Okay. So whatever differentiation is, we need to first differentiate both sides. Okay, we'll differentiate both sides with respect to x. So I have this, I have this. This would can be broken down this into this and into this. You know this, right?
Yes.
And for this side, I've been telling you that y is a function of x. Whenever we have two functions of x that are being multiplied and we need to differentiate it, we use the product rule. So by using the product rule, this function would come as it is. We need to derivate this function. What is the derivation of this function? Simply the function and its derivative with respect to x plus derivative of this first function, that is 4 into first function as it is. Okay. Next, we need to simplify this. This would be 3x square plus. Now, this is another game changer. When you are dealing with implicit differentiation, you'll get across such terms, okay? You'll get across such terms very frequently. And this is why I told you in the first slide that to simplify implicit differentiation questions, you'll be using product rule, you will be using chain rule. Remember, whenever you get across such type of a case, you need to use the chain rule. And what is the chain rule? The chain rule, you need this type of thing. Okay, fair enough. And you know that you cannot differentiate it directly, but you can differentiate it with respect to y. And you, okay, and to get this, you need to have a dy over here and a dx over here. This is how you apply chain rule. You need this. You cannot solve it directly, but you can derivate this y cube with respect to y. Okay, you can write it down. Now, once you have this, you have this. You know, in order to make this thing look like this thing, you need to have a dy over here. Just so you know the memory trick I told you, just to memorize it. That is how you apply the chain rule. Okay. Once you have applied the chain rule, simply this y cube would become 3y square. This would be dy by dx directly. And I took this expression to this side in order to make dy by dx the subject of this equation, because this is what we had to do. We were asked to find dy by dx. Okay. So once I had dy by dx on this side, I took dy by dx common, and then I simplified things, and then I plugged in 2's, and this was 2 square. So yeah, that is how you solve questions of implicit differentiation. Is it clear?
Yes, it is.
Okay, I'll stop the recording. I need to discuss something.